that we have removed the use of clone deep here in the handle send new message action method, we are going to do the same for the remaining methods of this UI store data reducer file. So we have a couple more methods. We have applied the same principles that we have shown here. In the case of the two remaining methods, we are going to review the new implementation together. So let's have a look at them. The first is the handle new message received action. So what have we done here? We are again creating a new object. Instead of doing a clone deep, we are creating a new object. We are reusing the participants because we won't be modifying the participants in this method. And in the case of the threads and the messages, we are creating a shallow clone of the threads and messages map. This means that we are taking properties with the same names, which are the threads IDs or the message IDs, and we are pointing these thread IDs or message IDs to the original objects, the threads or the messages. But the difference towards participants is that this is a new object that happens to point to the same threads or messages. This is not the exact same object, like the case of the participants. So we can see here what were the parts here that were based on mutability. Let's try to identify them. So here we are incrementing the messages counter. This is one part. The other one is we are pushing the new message that we received from the server. We are pushing it to associate it to a thread. And of course, we are also saving the message in the list of messages. So new messages arrived from the server and we are updating the store state. So what other changes did we need to do? So for example, here messages, because this is a new object that we created here, it's not the original object which was frozen. We can simply add here the new message to the messages object. This new object is mutable at this point. We have just created it here. So this statement will not cause a problem. Now here we are doing something else. We are pushing to an array, so we need here a mutable array. So what we have done here is we have created a copy of the thread, and then we have created a copy of the array itself. So we have changed the message ID's property of that thread and we have initialized it with a new array. This is not the original array which was frozen, and it's not the original thread which was also frozen. Now, with this new mutable thread that we have created, we are going to push the new message ID to the message ID's property array. And here we are incrementing the participants counter for the current participant. So as you can see, all this logic, it's very easy to get this wrong, but if by any chance we accidentally mutate something that is immutable, we are going to get immediately an error at runtime. Also, it's important to realize that if we don't need the performance boost that this will bring us, there is really no good reason to apply this because it really makes our reducer functions harder to write. Now, at this point in the reducer function, you might have noticed that we still have here an error, which is we are mutating directly the participants map of the thread. In order to avoid this, let's assign it to a newly created object. We are going to use the lodash clone utility, so this is not a clone deep. This is going to create a copy of the object. So this is an alternative here to using object.assign basically. And we're going to pass it in the reference to the participants object of the thread. So now what we have here is no longer an immutable object, so we can increment this counter here and everything will work as expected. Another thing that is worth doing at this stage is to use the shallow clone operator of lodash in the multiple places of our function. So let's say that, for example, we want to do here a shallow clone of threads. We can do so using the clone operator. It's a little bit more readable than using object.assign and the result is equivalent. So here we don't gain a lot in terms of readability, but take a look, this line here. We can also replace this line here and use underscore clone to clone the object, and we can do so in the remainder of the function. For example, here we can create a local variable that points to this thread. This thread here is the thread that is associated to the message, so let's call it the message thread, and we can use this variable here to make the reminder of our function a little bit more readable. So all these places where we are accessing the thread based on thread ID, we are always retrieving the thread associated to the message. Again here, this line where we are cloning the array, this can also be cloned using the --clone utility function. So using clone, we have less code and it's more readable, more understandable what we are trying to do here. Okay, so now at this point you are starting to see how these reducer functions are now written in order to ensure that we can keep references to the previous state if we didn't modify it. So now, for the sake of completeness, let's cover the last reducer function. So this is the handle thread selected action. So this is triggered whenever you are on the thread section list and you click on one of the threads. So let's take a look. Here we have created 3 copies, one of the participants, another of the messages, and another of the threads. Now let's take a look at what are the mutation operations that we are going to do here. We have here one mutation operation, which is to go to one of the threads and to set the messages and read counter for the current participant to 0. So one of the things that we already know is that we will have to do a copy of this thread object, because otherwise here we would be pointing to the immutable version that was previously stored on the state. So here we are creating a copy of the thread. So notice that we are taking the thread that corresponds to the selected thread ID, and using object.assign we are creating a shallow copy of it, and we are storing it here in the threads object of the new store state. So we have effectively here cloned the thread, but it's a shallow clone and not a deep clone. Now here we are creating a local variable that references the current thread in the new store state, so that to make it easier to implement the rest of the logic. Now to these participants here we are going to clone the participants of the thread. Now notice that here the current thread has a list of participants. So here we have effectively created a copy of the participants of the current thread. Now that we have a copy of the participants, we are going to set the counter of the current participant to 0. So this gives you an overall idea of how do we implement reducer functions in order to ensure that we have an immutable output, but at the same time, each time we don't create copies. If there are parts of the data that have not been changed, it's okay to point to the previous version of the data. So now that we have modified our reducer functions, let's make sure that the application is up and running. We are going to do npm start and make sure that the bundle is valid. Once the bundle is valid, let's take this for a spin. Let's switch back to the browser. So let's reproduce the usual scenario, the thread between Alice and Bob, just to make sure that everything is still working correctly. So let's exchange a few messages. Hello Bob. Hi Alice. So everything is still working as expected. But, and this is the catch, we are still not taking advantage of the on-push change detection. Even though we are not doing deep clones of the application state, even though the application state coming out of the store is immutable and points to previous versions of the data as much as possible, even in that case, each time that a new application state comes out of the store, we are essentially re-rendering the whole thing. So let's understand why in the next lesson.